Good morning, class. We're looking at Module 4, covering chapters 8 and 9. Here's chapter 8, part 2, polar coordinates and vectors, 8.4, 8.5, and 8.8. Polar equations and graphs, complex plane, De Moivre's theorem, and vectors. So when I plot the point -2, 0, and here's the polar axis along the positive side of the x-axis. Here's the pole. A point has coordinates x, y, or r, theta. So first we start with the theta, which is 0 along the positive side of the x-axis, and that we go 2 units to the right if it's positive. Because it's negative, we're going to go on the opposite side. 1, pi over 2. The positive side of y is the pi over 2. This side is pi, and the bottom is 3 pi over 2, 270 degrees. So we make the angle pi over 2, and then how many tick marks? 1 tick marks. We want to find other polar coordinates for part B. Polar coordinates are not unique. There are infinitely many ways of writing them. R, theta plus 2k pi. And that would be if we want to go with the positive R. If we go with negative R, we add odd multiples of pi, and remember k is an integer. So in this case, we want R to be positive, and we're going to go from 0 to -2 pi. All you have to do, subtract or add even multiples of 2 pi. In this case, because we want R to remain unchanged, we just add 2 pi, or in this case, we subtract 2 pi. So when we subtract 2 pi, we get 1, -3 pi over 2. In the second case, we want R to be negative, and theta between 0 and 2 pi. So all you have to do, just add odd multiples of pi. Let's just add pi, and we get 3 pi over 2. Remember, R has become negative. In this case, R is positive. We want to go from 2 pi to 4 pi. So let's add 2 pi, and it makes it 1, 5 pi over 2. So it's very straightforward. Plot the points first, then find their coordinates. For part A, find the rectangular coordinates 6, 150. This is polar, okay? We are going to graph it in a polar and then find the rectangular coordinates for it. So this is polar, and we want to find the rectangular format. So the idea is to make the angle first 150 degrees, and then we go 6 tick marks. So we count 6 circles, if you will, 1, 2, 3, 4, 5, 6 along the 150 degrees. So that's the angle, and that's the circle 1, 2, 3, 4, 5, 6. So that's the location. Polar has coordinates r, theta. Rectangular has coordinates x, y. X equals r cosine theta. Y equals r sine theta. So x equals r cosine theta, cosine of 5 pi over 6. Remember, 5 pi over 6. The reference arc is pi over 6. So the answer is just the same as pi over 6. You have to consider the quadrant, and therefore positive or negative. Cosine of pi over 6, square root of 3 over 2. In the second quadrant, cosine is negative. So minus square root of 3 over 2. 6 and 2 cancel each other. We get 3. So minus 3 square root of 3. Y is r sine theta. And as I mentioned, pi over 6 is the reference arc. Sine is positive in the first and second quadrant. So it's the same as pi over 6. Therefore, sine of pi over 6, which is 1/2, their product is 3. So this point r comma theta is the same as this point x comma y, 6 comma 150 degrees, is the same as negative 3 square root of 3, 3. This is polar, this is rectangular. Now find the polar coordinates. The pair is in rectangular format, and we go 2 units to the right and 2 units down. So 2 to the right, 2 down. And now we need to find r and theta. So if we have a rectangular and we're going to go to polar, x squared plus y squared equals r squared, and tan theta is y over x, adjust for the quadrant. So x squared plus y squared equals r squared. So 2 squared and then negative 2 quantity squared is 8. R is 2 square root of 2. I hope everybody knows by now. When you take a square root of 8 is 4 times 2. 4 comes out as 2. And tan theta is y over x, and you have to adjust it for the quadrant. And the reason you have to, of course, this is a common R. You don't need a calculator. But if you need a calculator, remember, the inverse function gives you from negative power 2 to power 2. That's why you have to adjust it. This is negative 1, and theta becomes negative power 4. So r is 2 square root of 2. Theta is negative power 4. And normally we want positive. If it's not mentioned, it's your choice. If you want it positive, that means you want it in the first complete revolution. You add a 2 pi to make it positive. And that results in 7 power 4 in case if need be. Transform the polar equation r cosine theta equals negative 2 to an equation in rectangular coordinates and graph. So here's polar, here's rectangular information that you need. And so r cosine theta equals negative 2. We also know x equals r cosine theta. And if we put them together, that means x must be negative 2. And you know x equals negative 2 is a vertical line. So if it's x and y, you go 2 units to the left for the location of its intercept. You draw a vertical line and you're done. This is negative 2 comma 0 if you go with it. So this is the two grids together, polar and rectangular. Transform the polar equation r equals 2 cosine theta to an equation in rectangular coordinates and graph. So here's the piece of information that we already have. X is r cosine theta, x squared is x, r squared is x squared plus y squared, and the given information is that r is 2 cosine theta. When we have r on the one hand and sine or cosine on the other, the technique, if you remember, was to multiply by r. So we are going to multiply both sides by r. The result is this is r squared, this is 2r cosine theta. As you know, r squared is x squared plus y squared. As you know, r cosine theta is x, so therefore the right side is 2x. And we move things so that 2x sits next to x squared. And now we look at this and we complete this square. B is negative 2 divided by 2 is negative 1. Squared is positive 1. So add 1 to both sides. What happens is this is x minus 1 quantity squared plus y squared, because always put the b over 2 including the sign. So x minus 1 squared plus y squared equals 1. And as you may recall, this is a circle centered at 1, 0 with the radius 1. Let me just remind you of what I'm talking about here. Class, x squared plus y squared equals r squared. That's centered at 0, 0 with the radius r. X minus h quantity squared plus y minus k quantity squared equals r squared. Centered at h and k, 1, and in this case there's nothing said, 0 with the radius r. Okay, so the radius is r, okay, centered at 1, 0 and looking like that. We are assuming that 2, because it would be too small, class, I took 2 of them to represent 1. Okay, so this would be 1/2, this would be 1. Transform the polar equation or cosecant theta equals 8 to an equation in rectangular coordinates and graph. Cosecant, 1 over sine. So it's r over sine theta. And you can take it to the other side. In other words, multiply both sides by sine theta. R becomes 8 sine theta. Now we are in business. The technique was to multiply by r both sides when one side is r, the other side involves sine or cosine. So let's multiply by r. R squared, x squared plus y squared. 8 r sine theta. R sine theta is y. So we are replacing it accordingly using this. We are going to move the 8y next to y squared. B is negative 8 divided by 2, negative 4. Squared is positive 16. Let's add positive 16 to both sides. So left side is x squared plus this one. How do you write it? Always the variable x, y, whatever in this case is y, and b over 2, including the sign. If it's positive 4, positive 4. If it's negative 4, negative 4. Quantity squared, this is 16. Which means it's a circle centered at 0, 4. Radius is square root of 16 or 4. Radius is square root of 16 or 4. So 0, 4, because that's large enough, we can go 1 tick mark as 1. So 1, 2, 3, the fourth circle is 0, 4. And of course, 0, 4 is along the positive side of the y-axis, or pi over 2. And therefore, we are going to graph this circle, resulting in a radius centered at 0, 4, with radius 1. So it's pretty straightforward, everybody. Identify, graph the equation, and convert to a rectangular equation, R equals 4. When you have R and a number, square both sides. R squared equals 16. This is the easiest format to represent a circle. So R equals 4 is the same as x squared plus y squared equals 16. As you know, this is a circle centered at the origin or pole with the radius square root of 16 or 4. So that's the circle. Really straightforward, everybody. Now, theta equals pi over 4. Theta equals 3 pi over 4. Anytime you have theta, remember the tangent and the concept of a tangent, which is y over x. So just take a tangent of both sides. That's all you have to do. Take a tangent of both sides. And so 3 pi over 4 is a common R. Pi over 4 gives you 1. 3 pi over 4 gives you negative 1. Tangent is negative 1. On the one hand, on the other hand, tangent is y over x. So look at this part. Do the cross product. Y equals minus x. And as you know, y equals x would be this line. Y equals minus x would be this line, a line through the origin. Okay. So again, pretty straightforward. So theta equals any angle represents some sort of a line through the origin. And of course, a common arc makes it easy to do it without a calculator. Now, identify the graph of the equation and convert to rectangular equation where r sine theta equals negative 3. And you know y is r sine theta. That means y must be negative 3. And y equals a constant is a horizontal line. So you go 1, 2, 3. Okay. 1, 2, 3 circles. That's this point would be 0, negative 3. You go 3 units down. R cosine theta is x, everybody. So R cosine theta is x. Therefore, x equals 4. As you know, x equals a constant is a vertical line. So you go 1, 2, 3, 4, and you draw a vertical line. you're going to move on, everybody. So in short, R equals A is a circle centered at the pole with the radius A. Theta equals alpha is a line that goes through the origin. Y equals tan of alpha, whatever that number is, times x. R sine theta equals a constant, that's a horizontal line, y equals A. R cosine theta is alpha. Again, alpha is a constant, becomes x equals alpha. It's a vertical line. And R equals plus minus 2a sine theta, cosine theta. All of them are circles. All of them have the same radius A. The center. For cosine, because cosine represents x and sine represents y, if you remember sine theta and cosine theta, right, for a unit circle. So for cosine, the center is along the x-axis, for positive at a0, for negative at negative a0, and for sine is along the y-axis, for positive 0a, for negative 0 minus a. That might be helpful to remember. We discussed the symmetry. Let's quickly go over that again. Symmetry with respect to the polar axis or the x-axis. If in the polar equation r comma theta can be replaced by r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis, looking like that. So r comma theta and r comma negative theta are on the graph. And symmetric with respect to the line theta equals pi over 2. That means in essence the y-axis. If in the polar equation r comma theta can be replaced by r comma pi minus theta, then it's symmetric with respect to the line theta equals pi over 2. Looking like that. And with respect to the polar origin, if in the polar equation r comma theta can be replaced by negative r comma theta or r comma theta plus pi. In other words, you have to check this. If it fails, you have to check this. As long as one of them works, the graph is symmetric with respect to the pole. Looking like that. Graph r equals 1 minus cosine theta. And as you recall, we started graphing just about any type of a graph by plotting points. So we can do the same thing here. And I remind you about the cardioids. R is a times 1 plus minus cosine theta, or a times 1 plus minus sine theta. It looks like a heart. A is positive, passes through the pole. Now, let's look at a simple pairs, 0, power 6, power 4, and so forth. We are picking up easy ones. So for 0, if I plug in here, everybody, I get 1. 1 minus 1 is 0. For pi over 6, as you know, cosine is square root of 3 over 2. So 1 minus square root of 3 over 2. Pi over 4, square root of 2 over 2, 1 minus that. Pi over 3 is a good number because cosine is 1/2. So 1 minus 1/2, that gives me 1/2. Pi over 2 is a good number, is 0. 1 minus 0 is 1. 2 pi over 3 is the same as pi over 3. However, remember the second quadrant, cosine is negative. So 1 minus negative 1/2, it makes it 3/2. And pi makes it negative 1. Negative times negative 1 is positive 1. They add up to 2. And those are the pairs. Okay. Uh, 0, 0, r comma theta class, remember, as long as r is 0, you are looking at the pole. And I'm going with 2 tick marks, going with 1 again, because just to represent a graph fairly decent. So that's 0, 0. Those you need a calculator, okay? So square root of 3 is about 1.7 divided by 2 subtracted 1. Square root of 2 is about 1.3, 1.4 divided by 2 subtracted from 1. Let's go with easy numbers. 1/2 and pi over 3. So you locate pi over 3 first, and you go 1/2, just one tick mark. Okay, because we said one tick mark is 1/2, 2 tick marks would be 1. So 1 pi over 2. So pi over 2 is easy up here, and one tick mark, we said this is 1/2, so this is 2. 2 of them makes it 1. Okay, 2 of them makes it 1. 3/2, 2 pi over 3. So you locate 2 pi over 3 and you go 3/2. That means 3 circles. Okay, so 1, 2, 3, and 2 pi. Pi again is easy. You go 2, that means you go 4 of them because we decided 2 tick marks is 1. So 1, 2, 3, 4, that's also easy. And it looks something like that. Now we can go with more points, but let's discuss this symmetry because you know cosine is an even function. So if I replace the theta with negative theta, since cosine is an even function, I get the same answer, 1 minus r equals 1 minus cosine theta. So it is symmetric with respect to the polar axis. Remember, when you change the theta, remember theta, let's say it's positive, minus theta is negative. It makes it symmetric with respect to the polar axis when r comma theta can be replaced by r comma negative theta, resulting in an equivalent equation. The graph is symmetric with respect to the polar axis, which means right here we get the same thing, if you will. Okay. Just by this, again, mine looks horrible. I'll show you a better graph, but that's the concept. Because of the symmetry, you don't even need more points. But if you were to pick more points, 4 pi over 3, okay, is the same as pi over 3. However, it's negative, so it actually makes it the same as 2 pi over 3, which is 1 minus negative 1/2 or 3/2. 3 pi over 2 is easy because it makes it 0, so 1 minus 0 is 1. 5 pi over 3 is the same as pi over 3 because cosine is positive in the fourth quadrant. So it's just the same as pi over 3 makes it 1/2. 2 pi is the same as 0, makes it 0. And you can graph those. But like I said, you can also use the fact that it's symmetric with respect to the polar axis. You can even say the x-axis ultimately means the same thing. Plot the complex number 1 plus I in the complex plane and write it in polar form. All right, let's discuss a few things. This rectangular coordinate system, now we have the x-axis as real part, y-axis as imaginary part. So z is x plus yi, or r cis theta. This is a shorthand notation of r times cosine theta plus I sine theta. This one, shorthand notation, is r cis theta. R squared is x squared plus y squared. And this is the modulus. This is not the absolute value, but looks like an absolute value sign. They call it the magnitude of z, or the modulus of z equals r equals square root of x squared plus y squared. Tan theta remains as y over x. As always, you want to adjust with the with respect to the quadrant if need be. So this is an imaginary line. This is a real line. So this one z equals x plus iy. This is theta. This is r. Now, z bar or z star is the complex conjugate, which is x minus yi. In this case, all you have to do, look at the coordinates and pay attention to the fact that the coefficient of I is 1. So locate 1, 1. This is 1, this is 1, and just throw it. And this would have been a good idea to perhaps use 2 tick marks as 1 again. That would look better. So we want to go with the polar format. So first find R, which is square root of x squared plus y squared. 1 squared plus 1 squared. That's R equals square root of 2. Tan theta is y over x, or 1. Theta becomes 45 degrees or pi over 4. That is a common arc. And so z is x plus yi, which makes it 1 plus I equals r cis theta. That means r cosine theta plus I. So that's the angle. And now we are going to replace the theta with 45 degrees and r with square root of 2. Write the complex number. 4 times cosine 7 pi over 4 plus I sine 7 pi over 4 in rectangular form and plot the complex number. So simply put, what is cosine and sine of 7 pi over 4? Again, reference are pi over 4. So it's the same as pi over 4. In the fourth quadrant, 7 pi over 4 is the fourth quadrant. Cosine is positive, sine is negative. Both of them are square root of 2 over 2. This is positive square root of 2 over 2. This is negative square root of 2 over 2. Remember, for pi over 4, both of them are square root of 2 over 2. And so you drop the denominator and you change the 4 to 2. So 2 square root of 2 minus 2 square root of 2i. This is 7 pi over 4. Theta is 7 pi over 4. And that's the point. You go 2 square root of 2 along the real and 2 square root of 2 down along the imaginary axis. So that's what you have. So about 2.8 roughly, less than 3. Okay, square root of 2 is about 1.4. ZW and Z, we want to find Z times W and Z over W and leave the answer in polar format. Z and W are given. So I'm going to remind you of the polar multiplication. Z1 times Z2, again, all of them are being repeated. R1, R2, cis theta 1 plus theta 2. That means multiply their magnitude and then add up their argument. So first, let's start with Z times W. So we're going to multiply the numbers in front, which are the modulus or the magnitude. So 2 times 2. And according to this, we are going to add up their arguments, the angles. Power 8 will be added to power 10. And 40 is the common denominator. Divided by 8 is 5. 5 pi divided by 10 is 4. 4 pi. So we get 2 times 2, 4. Cosine of 9 power 40 plus I sine of 9 power 40, or a shorthand notation 4 cis 9 pi over 40. That would be shorthand notation. Now, for the division, we divide their modulus, or their magnitudes. And then the arguments, we subtract the second one from the first. And that's easy calculation. I've already done that. 5 pi plus 4 pi now becomes 5 pi minus 4 pi over 40, which makes it pi over 40. And again, shorthand notation would be simply cis pi over 40. That would be the shorthand notation. Right, in standard form, when we say standard form or rectangular form means the same thing. So just we want z to the power of 6. So let's remind everybody of what we call the Moore's theorem. So if you have RC's theta and you want to raise it to the power of n, you raise the magnitude to the power of n, and then you multiply the argument by n. In this one, n is 6. So z to the power of 6. That means this piece to the power of 6. And this piece times 6, according to the Moore's theorem. Now, square root of 3 to the power of 6 is the same as 3 cubed. 6 goes away, 18 becomes 3. 5 pi over 3. By the way, 3 cubed is 27. And so 5 pi over 3, pi over 3 is the reference or cosine of 5 pi over 3 and pi over 3 are identical. This one is the same as negative of that. So this is 1/2 sine of pi over 3 square root of 3 over 2, and it becomes negative because sine in the fourth quadrant is negative. So you can just come up with the answer here or just change it in this fashion. And now, if you leave it like that, it's fine. If you apply the 27 distributed, it's just as good. 27 halves minus 27 square root of 3 over 2 times I. This is the A plus BI format, the standard format, or X plus YI format. Given z equals 1 plus I, let's find z to the power of 10. Okay, we first have to come up with 1 plus I, okay, in a polar format. And we just did that a moment ago in question number 9. It's been done. We just found that. We went over that, so I'm not going to repeat that. And now we want to raise this to the power of 10. I'm going to follow the De Moivre's theorem, which says raise square root of 2 to the power of 10, and this multiplied by 10. Square root of 2 to the power of 10 makes it 2 to the power of 5, and this is 450 degrees. Now, of course, 2 to the power of 5, everybody knows is 32. Now, let's get rid of 360 degrees because this is larger than 360 degrees. If I subtract 360 degrees, nothing changes. Now, cosine 90 is 0, sine is 1. So the answer is 32i. Given z equals 8, find the complex cube roots. There are 3 roots, and I want to quickly remind you of algebra class. If you have something like that, that means you are going to go with, I'm going to write it here, x cubed is 8, and you know one of the answers is 2 for the sake of argument. What happens to the other one? If you write them in this fashion, and as you recall, I want to remind you of a cubed minus b cubed is a minus b times a squared plus ab plus b squared. This is what we would have done if we wanted all the roots, including the complex numbers. And this would be x, remember this is 2 cubed, x minus 2 times x squared plus 2x plus 4. And this obviously gives you x equals 2. And this one, you know how to handle the quadratic, using the quadratic formula, you know how to handle quadratic equations. But this actually, believe it or not, makes it easier in essence. So we have this, and now the concept of a root. If we have the number in the form of RC theta sub 0, then and n is larger than or equal to 2, there are n distinct complex nth roots of w. Z sub is the nth root of r. So you take the nth root of r. And then r says, now you're going to put divided by n here and 2k pi over n, or if it's in degrees, 360k. Either way is fine. Okay. And you choose k from 0 all the way to n minus 1. If you go to n, it just goes back 1 revolution. So with that being the case, 8 is 8 cosine of 0 plus I sine 0. I've mentioned that before, and I've shown you that basically a positive number class, a positive number, any number, let's say 5, is 5 cis 0. If it's negative 5, is 5 cis pi, okay, or 180 degrees, okay? So following that, and let me, so theta 0 is 0, and then 2k pi over n. It doesn't matter. If you want to use the degrees because it's easier, by all means, you can do that. We are going to simplify this. This, of course, goes away, and this becomes 2, everybody. And k can be 0, 1, 2, because we want cube roots. We go all the way to 2. So if you plug in 0, okay, k is 0, you get 2 cis 0. If you put 1, you get 2 pi over 3. If you put 2, you get 4 pi over 3. So we get 2 cis 0, 2 cis 2 pi over 3, 2 cis 4 pi over 3. So those are the answers. Let's put them in. Let's put them in. So z sub 0 is 2 cosine 0 I sine 0. You know cosine 0 is 1. What color do I want to use? So this is 1, this is 0, so that's 2, and we already know that's one of the solutions. This one, 2 pi over 3, remember the reference arc is pi over 3. The answer is the same as pi over 3. Cosine is negative. In the second quadrant, sine is positive. And so it makes this one negative 1/2. This one positive square root of 3 over 2. You multiply it by 2, you get negative 1 plus I square root of 3. In the case of a 4 pi over 3, both of them are negative class, because in the third quadrant, both cosine and sine are negative. And if you go back to what I put up, and you use the quadratic formula on that, you go through the process, you get that one too. However, if the number is not like 8, where cube root is not 2, for example, let's say it's 4 or 5 or something like that, then this is the methodology. Let's look at vectors. Vector V has initial point P and terminal point Q. Write V in the form AI plus BJ, its components. Find its position vector, also find its magnitude. P has initial point of 3, 2, and Q is 5, 6. And reminding everybody that if you happen to have a couple of points representing a vector, okay, position vector is the one which has its initial point at the origin, okay? And so this distance is equal to this distance equal to this distance. Two vectors are equal if they have the same magnitude, the same direction. So position vector V. If a V with components A and B is an algebraic vector whose initial point is at the origin, then V is called a position vector. So this is a position vector, this is not. But going from here to position vector, we just follow this. V is AI plus BJ, A, B, where A and B are called components of the vector V. A vector with initial and terminal points, such as this, x of 1, y sub 1, and q x sub 2, y sub 2 is equal to the position vector x sub 2 minus x sub 1, y sub 2 minus y sub 1. So you can make it happen. And so with this being the case, we are going to write x sub 2 minus x sub 1. That means 5 minus 3. Y sub 2 minus y sub 1. That means 6 minus 2. And we get the position vector 2, 4. So that means you go 2 tick marks to the right, 4 tick marks up, and that's your vector. So this is 2, this is 1, 2, 3, 4, so something like this. This is the vector we are referring to. Okay, this 0.2, 4, and this is vector 2, 4. All right, and we can write it in this fashion: 2i plus 4j. I is the unit vector along the x-axis, j is the unit vector along the j-axis, along the y-axis, and they mean the same thing. So in this format, okay, or in this form. What is the magnitude of the vector? This is called the magnitude. It's square root of a squared plus b squared. And it must be greater than or equal to 0. If it's 0, the vector is 0. And two vectors that are opposites, they have the same magnitude. If you multiply it by a number a, you can take that out as an absolute value. And so with that being the case, following this formula, now we are going to say square root of 2 squared plus 4 squared, or this one, 2 squared plus 4 squared. This is 4. This is 16. They add up to 20, and 20 is 4 times 5. 20 is 4 times 5. 4 is erased up. 4 comes out as 2. So we have learned about position vector, magnitude, and components of vector. Given V is negative 2i plus 3j and W is 5i minus 4j, find the magnitude of V plus W and 2V minus 3W. So magnitude is square root of A squared plus B squared. It's very simple. So for V, a negative 2 quantity squared plus squared under the radical 4 and 9 is 13. V plus W, we just add them up component wise, which means these two will be added. We get 3i, and these two will be added. We get minus j. That's the meaning of it. So here's the u, here's the v. So you connect the initial point of u to the terminal point of v, you get u plus v. Here's w, you connect them and you get this red line, which is u plus v plus w, and you can put it in any order. 2v minus 3w, so 2 times, let's multiply it by the components. 2 times v, we put the v and we get minus 4i plus 6j here. We get minus 15i plus 12j here. These two add up to negative 19i. And these two add up to 18j. So very straightforward. Find the magnitude, direction, angle, and a unit vector in the same direction for the vector v equals 3i plus 3j. And we are reminding everybody of the position vector, the magnitude, as always, tan of alpha b is b over alpha. So the magnitude, we just follow that. This is 9, this is 9, we get 18. And I hope you know 18 is 9 times 2. 9 comes out, comes 3. Now, the direction. Let's look at the concept of a direction. A vector is the product of its magnitude and the unit vector in the same direction, cosine alpha I plus sine alpha j, where this angle is alpha. This is the unit vector. So the unit vector times the magnitude gives you the vector itself. And the direction, we normally go with the positive alpha and between 0 and 360 degrees, or 2 pi. Okay, and it's the angle between the vector and the positive side of the x-axis, between v and I unit vector along the x-axis, j is the unit vector along the y-axis. And so if the vector is 3i plus 3j, we need to calculate the alpha. So simply tan is b over a, or 3 over 3, which makes it 1. And it's a common arc that gives us power for 45 degrees. Therefore, according to this formula, the vector is its magnitude, which is 3 square root of 2, and cosine of alpha I, sine of alpha j. Replace the magnitude with 3 square root of 2, alpha with 45 degrees. So that's the magnitude, the direction angle, and writing the vector in that format. Now, the last piece is asking, we want to find a unit vector in the same direction. The methodology is to divide the vector by its magnitude. So simply put unit vector in the direction of v is the vector divided by its magnitude. So V has components A, B. So A times 1 comma 0 plus B times 0 comma 1 is AI plus BJ. This is another way of representing that. So the vector has to be divided by its magnitude, which is 3 square root of 2. So 3I plus 3J divided by 3 square root of 2. As you know, I can drop this 1 over square root of 2. And 1 over square root of 2 is square root of 2 over 2. So it's square root of 2 over 2 I plus square root of 2j. Or you may recognize it right here, everybody, that this is 3 square root of 2 times this part. This is the unit circle along the vector. So I hope you realize that this would be the answer, the same as what you're looking for. Cosine of 45 and sine of 45 are both square root of 2 over 2. Write the vector V in the form AI plus BJ given its magnitude and the angle alpha it makes with the positive x-axis. Also, find a unit vector and check its magnitude to be 1. By that, we mean a unit vector in the same direction as V. All right. Let's start with the formula. V is its magnitude times its unit vector. So we replace this with 14 and alpha with 120. As you know, reference arc becomes 60 degrees. And in the second quadrant, cosine is negative, sine is positive. So the same as 60 degrees would be 1/2. This is negative 1/2. This would be square root of 3 over 2. And just divide 14 by 2, you get 7. So minus 7I plus 7 square root of 3j. So that's pretty straightforward, everybody. So simply put, this is really this part, everybody, which is this part, is the unit vector. Or just divide the result by 14. Okay, that's the unit vector. You really don't have to do much. Unit vector has been calculated already, in essence, because this is your unit vector, everybody, in the same direction. Unit vector in the same direction. Now, to make sure that it is a unit vector, you can check it by simply calculating its magnitude must be 1. So this number to the power of 2, this number to the power of 2. So this gives you 1/4, this gives you 3/4. It's 1. Square root of 1 is 1. You can even stop here. You're checking the magnitude is 1. Okay. Any vector with the magnitude 1 is considered a unit vector, everybody. Pretty straightforward. And as I mentioned, if you didn't want to redo this, just write this one as a unit vector and you're fine. A plane is flying at a speed of 200 miles per hour on a bearing of north 55 degrees east. The wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of the plane to the nearest mile per hour and the true course of the plane to the nearest tenth of a degree. And again, we are reminding about magnitude, tangent, and a vector, which is the product of its magnitude and unit vector. So, it's doing 200 miles per hour in the north 55 degrees east, which makes this angle 55 degrees. So this is the velocity with respect to the air that it has. And if this is 55 degrees, the entire angle is 90 degrees. This must be 90 minus 55 or 35 degrees. We need that one. And so this vector has magnitude of 200 miles per hour, the speed or the magnitude, and theta of alpha is this angle, not the 55 degrees. So 90 minus 55 or 35 degrees. The wind is blowing from west to east. So that has a speed or magnitude of 35 miles per hour, and this is parallel to the x-axis, 0 degrees. And this would be the velocity with respect to the ground, this vector with this angle theta. So the ground speed is the magnitude of that, and the true course is north east. What is the angle in between? This angle, which is 90 minus theta. So this angle creates 90 minus theta, okay? So it's going northeast, the angle in between, this is the one, 90 minus theta. So I'm explaining how we are going to approach this. So we are going to add these two vectors to get V of G. To do that, VA is 200. We are going to write it in this fashion. 200 cosine of 35 R degrees I plus sine 35 degrees J. And this is not a common part. You have to put it into a calculator. Whatever the answer is, you multiply by 200. And you get the following 163.83 I plus 114.72 J. And this one is simply 35 times this, if you will, cosine of 0 degrees, sine of 0 degrees, and cosine is 1, but sine is 0. So you get 35i. So if you add them up, these two add up. And when we add those two, 35 and 163.83 gives us 198.83i plus 114.72. So that's the vector with its component. You need to find the velocity by the speed by finding the magnitude. So the magnitude is square root of a squared plus b squared. This number, square it, this number, square it, and add them up. Put it into a calculator, take a root, you get 230 miles per hour, roughly. Tan of alpha, okay, this angle, okay, this angle, remember, Tan of alpha is b over a. So in this case, we're going to go with theta, of course. It's this number 114.72 over this number 198.83 because it's b over a. Again, this is put it into a calculator, tan inverse of that number, that results in about 30 degrees. So this is 30 degrees. So we have the magnitude and we have this angle. So what is this angle? It's 90 minus that. So it's 60 degrees. So it's doing 230 miles per hour, going north 60 degrees east. That's the true course. The dot product. The dot product of two vectors has many applications with the following algebraic definition. It is also called scalar. It's a number. If we have vectors v and w with their components, then their dot product, you multiply the components a1, a2 plus b1, b2. The symbol v dot w is read v dot w. The dot product is also known as a scalar product or the inner product. The result is a real number and not a vector. Properties. When you multiply them in any order makes no difference. When you multiply a vector by 0, you get 0. The product of the two gives you the magnitude squared. If you multiply it by alpha in any order makes no difference. And VW in this format becomes the magnitude of V times magnitude of W times cosine of theta. Cosine of theta can be their product divided by the product of their magnitudes. So find the dot product and the angle between the two vectors. So the dot product is very simple. Just multiply the components, which means 4 times 1, negative 3 times 2, and add them up. And we get negative 2. So that's pretty straightforward. Let's graph the vectors. So we are going to go 4 to the, for this one, 4 to the right, 3 down. For this one, 1 to the right, 2 up. Okay. And we want to find the angle in between. So cosine theta is their dot product divided by their magnitude. So what is the magnitude? The magnitude is square root of a squared plus b squared. So this one would be square root of 4 squared and negative 3 squared. This one would be the square root of 1 squared and 2 squared. So 4 squared is 16, negative 3 squared is 9. They add up to 25. This is 1, this is 4. They add up to 5. This comes out as 5. So we have this product negative 2. We have kept the negative sign, as you can see, and negative 2 over 5 squared of 5. You can leave it like that, or if you rationalize it, you get 2 squared of 5 minus 2 squared of 5 over 25. Theta is the cosine inverse of that. You put that into a calculator, it gives you 100.3 degrees. All right. So that's very straightforward. Finding angle between two vectors show that the pair of vector is orthogonal. Well, orthogonal vectors. Two vectors are orthogonal when the angle between them is a right angle, 90 degrees. The dot product of the two is 0 because theta is equals to pi over 2. So their dot product is this times that times cosine of pi over 2, which is 0. So their dot product must be 0. Okay. So let's do their dot product. To show that they are orthogonal. Orthogonal, in essence, if you have two lines, they're perpendicular. That's the same concept for vectors. Orthogonal versus perpendicular. So 2 times 6 is 12. 3 times negative 12. Negative 4 is negative 12. They result in 0. Now, these two vectors show that they're parallel. Uh, Parallel vectors. Two vectors, V and W, are parallel when the angle between them is either 0, the vectors point in the same direction, or 180 degrees, theta equals pi, the vectors point in opposite direction. In other words, V equals alpha times W. So if one is the multiple of the other, that in times any real number, that means they are parallel. This is one way to do that, and the second method. So first and foremost, one method is to notice W is 2 times V. If you multiply this one by 2, you get 6i minus 2j, or V is 1/2 W. If you show that W is 2V, this is the proof, and you're done. Okay, everybody? You're done. That works just as good. Okay. The second method, we are going to find the cosine by finding V times W, their dot product, and dividing by the product of their magnitude. So this one is 3 times 6, 18, plus negative 1 times negative 2 is plus 2. This is 3 squared plus negative 1 squared. This is 6 squared plus negative 2 squared. So I hope you recognize this is as 18 plus 2. So 3 squared and negative 1 squared. Okay. Now, this for the denominator, I mean 3 times 6 plus negative 1 times negative 2. Okay. And square root of 10, for example, is 3 squared plus negative 1 squared. Okay, that's how you get 10. For 40, you get 6 squared and negative 2 squared under the radical. That's how you get that. And square root of 400 is 20. You get 1. Theta is cosine inverse of 1, which is 0. Find the vector projection of V equals I plus 3j onto W equals I plus j. Decompose V into two vectors, V1 and V2, where V1 is parallel to W and V2 is orthogonal to W. Go over the concept first. Vector projection, the components of V along W may be found by projecting the endpoint of V onto the line N containing W. For this reason, the magnitude of V times cosine theta is sometimes called the projection of V on W and is denoted by projection of V onto W with magnitude, which is the component of V on W, a scalar. So we have the formula V1 is projection of V onto W or V dot W over the magnitude of W squared times W. V2 is V minus V1. Component of V onto W is the magnitude of projection of V onto W. What do we mean by that? A picture is worth 1,000 words. So if you have the V, okay, you basically drop a perpendicular. Let's assume this line is along the x-axis. Doesn't have to be. But if first we go with the easy one, just drop a perpendicular. This becomes V1, okay, and then draw this line, make a right triangle. This one is the same as this one. So V1 and V2 are components of V. In fact, V1 and V2, they add up to V. Very simple. That's the concept. If it's going this way, you drop the perpendicular, it goes on the negative side of, let's say it's the x-axis, it doesn't matter. And then this opposite side is V2. Again, V1 and V2, they add up to the V vector, okay? And this is important when you want to find, for example, a weight and so forth. This right now is going up the ramp, and this has a weight. The weight is always towards the center of gravity, towards the center of the earth. So this is the component. This is the vector F, which represents the weight. You cut it into two components, always if it's going up the ramp, one that is parallel to the ramp and one that is perpendicular to the ramp. Therefore, if you draw a line which is parallel to the ramp and you drop a perpendicular, then this becomes F1, and this, which is equal to this, becomes F2, and the vector weight, which is F, is the sum of F1 and F2. So we have the formula. So with that being the case, let's first craft this I plus 3j. That means go 1. Again, in this case, 2 tick marks represents the one class. So this represents 1, then this represents 2. Okay, this represents 3, okay, along the x-axis. However, 1, 2, 3, 4, 5, 6, along the y-axis, only 1 tick mark, because the x and y, they don't have to have the same scale, okay? So I plus, oh, we have the same. Well, we happen to have the same scale. My apologies. So let me erase it. So this is 1, 2, 3. Okay. 1, 2, 3. But I thought we had different scales. We could have different scales. So 1 and 3. And this one is 1 and 1. Okay. V1 is their dot product V dot W over the magnitude of W squared times W. Okay. So in other words, class, what you're doing, you extend this, the concept again. What color do I want to use? If you extend this and now drop a perpendicular, because this is the W, drop a perpendicular onto W. This makes a 90-degree angle. And so this one is V1. This one, or you can draw it this way, is V2. That's what we're saying. We cut it into two pieces because we are given the W. All right, so let's plug in V dot W. So 1 times 1, 3 times 1 is the numerator. W is 1 plus 1, okay, or square root of 2 squared times W. So we write that. Let me erase my work again. So again, 1 times 1, 1 times 3. This one is 1 squared, and 1 squared is 2, and square root of 2 times W. And so as you can see, this is 2, this is 4. 4 divided by 2 is 2. 2 times W. So 2 times W becomes 2I plus 2J. Okay, so 2I plus 2J. What about V2? Simply put, the fastest way is to subtract V1 from V. And we get minus 2I here, minus 2J. These to add up to negative I, and these to add up to J. And that's the graph. Take a look. This is V1, 2 times I plus J. This is V2 minus I plus J. Find the work done in pushing an automobile along a level road from a point A to another point B, 40 feet from A, while exerting a constant force of 90 pounds. Okay, a couple of things that we want to discuss. Work is the result of a force being applied to an object over some distance, which in turn may change the object's total energy. When the amount of force varies, we use calculus. Work equals force times distance, W equals Ft. So that's a piece of information from physics. Force, F equals m times a. If it's a weight, a is the acceleration. If it's weight, acceleration is due to gravity, m times g, where g is 9.8 meter per square second. Work is Wf times d. What is given? The force is 90 pounds, and the distance is 40 feet. And because it's in the same direction, and because it's constant, simply F times d. 90 times 40. 3,600, the units would be foot-pound in the old British system. Just to discuss some interesting ideas from physics. Joules, 1 joule is 1 Newton times 1 meter. That means 1 kilogram meter squared over second squared. Joule, unit of work or energy in International System of Units, SI. It is equal to the work done by a force of 1 Newton when its point of application moves 1 meter in the direction of the action of the force. Okay, James Prescott joules. It equals 10 to the power of 7 ergs, and it's approximately 0.7377 foot-pound. The relationship between the two, you don't have to worry about this too much, but just I thought, at least some information given would be nice. A child pulls a wagon with a force of 50 newtons. The handle of the wagon makes an angle of 30 degrees with the ground. Find the work done in moving the wagon 100 meters. So what is given is that the force is 50 Newton and the distance is 100 meters, but it's not along the same direction. Okay. It's pulling this way. So you really need the component along the horizontal line in essence. So it's not the entire force that is being used, but rather a component of it takes it this way. That's the concept we need to pay attention to. So first and foremost, we position the vectors in a coordinate system in such a way that the wagon is moved from 0, 0 to 100, 0. The motion is from A equals 0, 0 to B equals 100, 0. So we mean from A to B, 0, 0 to B, 100, 0. Okay. And so this AB is the distance, which is 100I, right? If you want to write it as a position vector, okay, you get 100I, right? Plus 0J. F is 50 cosine 30I plus sine 30J. And cosine is square root of 3 over 2. Sine is 1/2. And W is FD. So we're going to multiply this, the two. In other words, in this case, is the product. F times AB is 50 times square root of 3 over 2 plus 1/2 J times 100I. So when we multiply these two, and then we multiply these two, as far as the dot product is concerned, these two can be multiplied because they're in the I direction, and this one in the J direction. I times J is 0 because one is in the I direction, one is in the J direction. They make a 90-degree angle in between. This is 5,000 times square root of 3 over 2, and we get 2,500 square root of 3. This is joules, everybody. This capital J represent the units, joules.